Next problem on diagonalization. Diagonalize the matrix. Diagonalize the matrix A equal to 1, 1, 3, 1, 5, 1, 3, 1, 1, and specify the matrix transformation. And specify the matrix transformation. Specify the matrix transformation. Also find a to the power of 4. Also find a to the power of 4 solution. Now this matrix, in this matrix, diagonalization is possible by using what method? Similarity transformation. Similarity transformation. So first let us find eigenvalues of the matrix. Matrix A is what? This is 1, 1, 3, 1, 5, 1, 3, 1, 1, 3, 1, 1. Characteristic equation is determinant of A minus lambda I equal to 0. Nothing but 1 minus lambda 1, 3, 1, 5 minus lambda 1, 3, 1, 1 minus lambda equal to 0. Then what are the eigenvalues? After solving this one, what this equation, okay, if I write this one equal to, if I expand this determinant, I'm getting this is 1 minus lambda into 5 minus lambda into 1 minus lambda minus 1 into 1 minus lambda minus 3, 1 minus this one gone, yeah, wait, this, yeah, next plus 3 into this is 1 minus 3 into 5 minus lambda equal to 0. You simplify this and solve this. The eigenvalues are minus 2 comma 3 comma 6. Eigenvalues are minus 2 comma 3 comma 6. Okay, now case 1 are the eigenvalues. And one more point you write, since the eigenvalues are distinct, the corresponding eigenvectors are linearly independent. So definitely diagonalization is possible. Therefore diagonalization is possible. Okay, now case 1 here, what is this? For lambda equal to -2, lambda equal to -2, consider the system. What is the system to get eigenvector? A minus lambda I into x equal to 0, that is a plus 2i you will get into x equal to 0. So what is this a plus 2i? This lambda is -2, just 1 plus 2, 3. So 3 comma 1 comma 3. Next one -2 na 1, 5 plus 2, 7 comma 1, 3, 1, 1 a minus lambda 1 minus lambda 1 plus 2, 3 into x equal to 0. Okay, now reduce to echelon form. First one is anyway R3 minus R1 clearly, and next one, second row, 3R2 minus R1. 3R2 minus R1. So 3, this is 0, this is 0. Coming to this is 21. 21 minus 1, 20. Coming to this 3. 3 minus 3, 0. Anyway, this is 0, this is 0 into x equal to 0. So I'm getting what? 0 row. I'm not writing all these things. Non-zero solution exists, obviously. So this is 3x plus y plus 3z equal to 0. And another one is 20y equal to 0, this part. So y equal to 0 is one value. Then what is this part? 3x equal to minus 3z. So x equal to minus z. x equal to minus z. Combining these two, we have x by 1 equal to y by 0 equal to z by negative 1. Therefore, eigenvector, first eigenvector is capital X1 equal to 1, 0, negative 1. First one is over. Coming to second case. Case 2, what is the eigenvalue? Next eigenvalue, I think 3. So consider the system a minus lambda I into x equal to 0. That is a minus 3i into x equal to 0. So what is a minus 3i? This is 1 minus 3 minus 2, 1, 3. Next, second row 1, 5 minus lambda, 5 minus 3, 2, 1, 3, 1, 1 minus 3, 1 minus 3 into x equal to 0. Next one. What are the operations here? 2r2 plus r1 is 1. 2r3 plus 3r1. 3r1 to reduce to get the echelon form. Then what is this? Where this implies this is negative 2, 1, 3. Next one, this is 0, this is 0. Okay. Next one, this is 2r2 plus r1, 4. 4 plus 1, 5. And this is 2. 2 plus 3, 5. And coming to this, 2. 2 plus 3, 5. And this is minus 4. Minus 4 plus 9, 5 into x equal to 0. So what is this? Is next operation r3 minus r2 to get echelon form 2, 3. This is 0, 5, 5, 0, 0, 0 into x equal to 0. So this is we are getting 0 row here. So it is echelon form. So writing echelon form into system of equations. First equation 5y plus 5z equal to 0. Second equation. So y equal to minus z. Substitute y equal to minus z here. Minus z plus 3z equal to 0. This is 2z. So 2x equal to plus 2z minus 2x equal to plus, that is 2z. So what I am getting, x equal to z. Combining these two for z. Combining these two for z. What I'm getting, this is x by 1 as well. Then y by minus 1 you will get z by 1. Okay. Take this minus sign this side. Take this minus sign this side. That is z equal to. Therefore, eigenvector is second eigenvector x2 equal to 1 minus 1, 1. Second is also over. Now coming to third one. Case 3. For lambda equal to, what is the third eigenvalue? 6. So consider the system a minus 6i into x equal to 0. So what is a minus 6 from diagonal? 1 minus 6 minus y, 1, 3, 1, 5 minus 6, 1, 3, 1, 1 minus 6 into x equal to 0. Now the operations are to get echelon form 5r2 plus r1. Next 5r3, what is this? Plus 3r1. So minus 5, 1, 3. This is 0, this is 0. Coming to this, minus 5 plus 1, minus 4. This is 5, 5 plus 3, 8. Coming to this, 5, 5 plus 3, 8. Coming to this, minus 25. Minus 25 plus 9. Minus 25 plus 9, minus 16. Next operation is what? R3 plus 2R2. Minus 5, 1, 3, 0, minus 4, 8, 0, and this is 0 definitely. And this is what? Minus 16 plus 16, 0. Yeah, we are getting 1, 0 row. If eigenvalue is not repeated, then we will definitely get 1, 0 row. So writing echelon form minus 5x plus y plus 3z equal to 0. Second one, minus 4y plus 8z equal to 0. So y equal to what? 2z. Y equal to what? 2z. Or I can write y by 2 equal to z. Z value I'm taking. Okay. Now substituting that y equal to 2z here, minus 5x plus 2z plus 3z equal to 0. So 5x equal to 5z you will get, I think, minus 5z. Yeah. X equal to z. So combining these two, what we have, x by 1, y by 2, z by 1. So third eigenvector is, therefore, eigenvector is x3 equal to 1 to 1. 1 to 1. Now eigenvalues over, eigenvectors over. Therefore, now group these three eigenvectors. Group the eigenvectors x1, x2 and x3 to formulate the matrix transformation. Nothing but what? Model matrix. That is P. P stands for what? X1, X2, X3, right? This implies, what is the matrix P? What is the first eigenvector? 1, 0, minus 1. 1, 0, minus 1. 1, 0, minus 1. And what is the second eigenvector? 1, minus 1, 1. 1, minus 1, 1. Right? And the third eigenvector, 1 to 1. This is 1, minus 1, 1. 1 to 1. 1 to 1 is the matrix transformation. Okay, one is one. Now diagonalization. Now by using diagonalize the matrix, that is the question. Now by using similarity transformation. Now by using similarity transformation, what is the similarity transformation? P inverse AP equal to D. What is that D? Lambda 1, 0, 0, lambda 2, 0, 0, 0, lambda 3. Diagonal matrix in which diagonal positions are eigenvalues. By using similarity transformation, we have, that implies P inverse AP equal to D equal to, what are the eigenvalues? We have taken order, minus 2, next one 3, next one 6 is the diagonal form. Of A. One part is over. Now, what is the next question? Now we have to find A power 4. Powers of A, I told you. Okay, powers of A. What is that? We have P inverse AP equal to D. That implies, I already told you, what is A equal to? First multiplied by P on both sides, D next multiplied by P inverse. This P comes here, this first P comes here, and the P comes here as P inverse. P inverse comes as P and P comes as P inverse. Okay. And what is A power 4 formula? Already I derived this. P just D power 4 P inverse. Okay, so I need what? D power 4. Now, first one, D power 4. What is D power 4? Simply minus 2 power 4, 0, 0, 3 power 4, and 0, 0, 6 power 4. That's it. For diagonal elements, this one, 2, this is 16, 0, 0, and 0, this is 81, 0, and this is 0, 0, 6, 6, 36, 36, 12, 96. D is over. Now, I know P value. I have to calculate what P inverse now. Okay, I have to calculate. Now we have to find. Now we have to find P inverse. Okay, what is P inverse? In your intermediate technique, adjoint P by det P. Adjoint P by det P. Now, what is determinant of matrix P? Determinant of what is matrix P here? 1 0 minus 1. Next one, what is the matrix P? 1 0 minus 1, 1 minus 1 1, 1 2 1. 1 minus 1 1, 1 2 1. What is the determinant now? This determinant value, this is 1 into minus 1 minus 2. And next to this, I'm expanding by column, 0 into something. Next, minus 1 into this is 2 plus 1. This is minus 3. And this is minus 3, minus 6. Determinant is minus 6. Any corrections right now? Okay, next one, adjoint P. Adjoint P, I think already all of you know adjoint P matrix. Just give me a minute, all of you. One important call. Now, adjoint P means what? It is the transpose of cofactor matrix. Cofactor matrix. Okay, transpose of cofactor matrix. I think you calculate this, you know, intermediate technique, and I'm giving directly the adjoint P value. This is 3. Shall I calculate? All of you tell, do you remember adjoint P, or can I do? Yes. Okay, let me calculate. First one, for 1, this is 1 1 position. What is the I am giving this? What is this one? This matrix is what? Transpose of cofactor matrix means cofactor of element means Aij. For example, cofactor of Aij means minus 1 whole power I plus j, and delete ith row jth column and write its determinant. So first one, 1 1 position, plus sign. This one gone, minus 1 minus 2 minus 3 I will get. Next, coming to this position, this is a 1 2 position. 1 2 position means 1 plus 2 negative. So delete this 0 0, and this is plus 2 multiplied by this minus sign, plus 2 multiplied by minus sign. So this is minus, and this is 1 3 position. So 1 plus 3 4 positive. This one gone 0, and this is negative 1. Okay, next, what is the first one? This is minus 1 minus 2 minus 3. Let's see, is it correct? Right. Any corrections? 1 0 minus 1 1 minus 1 1 1 2 1. Correct. Next one, coming to this position, 0. This is negative value. This one gone, 1 minus 1 0, right here 0. Next one, this position, 2 2 position, plus 2 2 position means plus. So this one gone, 1 plus 1 2, right here plus 2. Next value, coming to this value, this is 2 3, negative value. So negative value means this one gone, 1 plus 1 2 minus 2 you will get here. Once again, this 1 plus 1, right. Coming to this is 3 1 positive. So this one 2 plus 1 3 positive. This is negative. This one gone 2. So minus 2. Transpose I am writing directly. Next, this is plus. This one negative 1. So this is the matrix. 3 minus 2 1. So what is this one? P inverse now. Adjoint P by determinant P. What is determinant b? Minus 6. So 1 by 6 I'm writing. This is 3. Minus is including x1. This is 2. Minus 2. 2. 1 to 1. 1 to 1. Okay. This is p inverse. Therefore, a power 4 equal to what? P d power 4 p inverse. Isn't it? Right? P d power 4 p inverse. Substitute every value here. Now, matrix P. What is the matrix P? 1 0 minus 1 1 1 0 minus 1 2 1 1 1 0 minus 1 2 minus 1 1 1 minus 1 1 1 and d power 4. What is this? 16 0 0 0 81 0 0 0. What is this? 1296 and 1 by 6 is here. Okay. 3 2 1 0 minus 2 2 minus 3 2 1. So finally a power 4 value is after simplification this is 2 power 15 251 485 235 485 1051 485 235 485 251. This is a power 4. This is complete problem. Finding diagonalization. Next one for eigenvalues, eigenvectors. Next diagonalization. Next powers of a, that is a power 4. Here I solved the problem in the textbooks because values are very big. It is time taken. Okay. Now you take some assignment problems based on diagonalization. Based on diagonalization. If a equal to 5 3 1 3, find a power 4. Okay, this is using diagonalization. Next question, diagonalize the matrix. Diagonalize the matrix A equal to 3 negative 1 1 negative 1 5 negative 1 1 negative 1 3 and evaluate a power 4 and evaluate a power 4. Okay. 1 0 0 0 3 minus 1. Okay, next one, is it symmetric? 0 3 minus 1 0. Yeah, it's symmetric. No, that's it. These two problems are enough, simple problems. Next topic, any doubts in this diagonalization, all of you? Any doubts? Yes, anyone? His voice is audible?
Yes, sir.
No doubt now.
Yes,
Diagonalization. Next topic is quadratic form. This is very important, quadratic forms, and the next orthogonalization. Definitely one essay question will be there in quadratic forms with orthogonal transformation. What is actually quadratic form? First thing, you write like this. An expression which is uniform in degree 2 is called quadratic form. That is, for example, in two variables, a x square, a is the constant, 2hxy plus by square is q dot f stands for quadratic form in x and y. Quadratic form in x and y. What is the meaning of this uniform in degree 2 means here degree 2, here 1 plus 1 2, here 2. Each term is of degree 2. Each term is of degree 2. That is called uniform in degree 2. This is quadratic form in two variables. Similarly, ax square plus by square plus cz square 2hxy 2h, next one 2f or g 2gxz 2fyz is quadratic form in three variables x, y and z. Quadratic form in three variables. This is what degree 2, degree 2, degree 2, 1, 1, 1, 1, 1, 1. Done? It is a quadratic form in three variables. Similarly, you can define in four variables. Okay. Now, expressing quadratic form. Expressing quadratic form in matrix form. In matrix form. Okay. Now, every quadratic form can be expressed in matrix form as x transpose ax. X transpose ax. Remember this. X transpose ax. And what is x? What is a? Let us see. For example, first one, ax square plus 2hxy plus by square. How many variables are here? Two variables. Here, matrix x is, it's a column vector xy. Therefore, what is x transpose becomes what? Row xy. Okay. And the coefficient matrix is now this is A. All of you, listen carefully. How to write coefficient matrix? Now I'm telling. How many variables? X denote this x as 1. Y as second variable. So what is this position? 1 1 position, 1 2 position, 2 1 position, 2 2 position. Right? Here 1 1 means what? 1 1 means what? X into x. X into x. 1 means x into x. This is x into y. This is y into x. This is y into y. Nothing but y square. And this is x square. Now, in 1 1, this is 1 1 position. That is x into x. That is x square quotient you write here. What is the x square quotient? A. So, in 1 1 position, write A. Similarly, this is 2 2 position. 2 2 means what? Y into y. Y square quotient. What is that? Write B in 2 2 position. Write B in 2 2 position. Now, what is this position? This is position is 1 2 and 2 1. Both are same. 1 2 2 1 means x into y or y into x. Both are same. Now, what is the xy quotient here? 2h. Since xy quotient is placed in two positions, let us divide this 2h equally in these two positions. 1h here, 1h here. In 2h value, take half h here, half h here. Then this is xy position, yx position. This is coefficient matrix. Now see, then all of you, x transpose ax. What this becomes? X transpose means what? Row. This is hb. And this is what? xy. This is what? 1 by 2, 2 by 2, this is 2 by 1. Let us multiply this. What you will get? Let us see. First, these two matrices. 1 by 2, 2 by 2 means 1 by 2 matrix you will get. So, for what is the 1 1 position? Ax plus hy. Next, coming to this 1 2 position is what? Hx plus by. This is multiplied by what? Xy. This is 1 by 2 and this is 2 by 1. So, 1 by 1 you will get. What is this? Ax square plus hxy. Next, this into y. hxy plus by square. So what I'm getting finally, ax square plus 2hxy plus by square, the quadratic form. So each quadratic form can be written in matrix form as x transpose ax. X transpose ax. I think once again I will explain this, how to write this. X stands for 1, y stands for 2. Assume like that. Just I'm taking one dummy recognition. Then 1 position means what? X into x. That is x square quotient is what? A. Place A in 1 position. Same logic. 2 position. That is y into y. Y square quotient is what? B. Place B in 2 position. Now coming to this 1 2 position and 2 1 position. 1 2 position and 2 1 position. This is x into y. This is also y into x. Nothing but x into y. So x into y coefficient is what? 2h. Since x into y is placed at 2 positions, place 2h equally at 2 positions. 1h here, 1h here. That's it. All of you, is it clear? Is it clear?
Sir.
Yes, sir.
Niharika, are you there? Niharika. Next, coming to another quadratic form. Ax square plus 2hxy. No, 3 variables I will take. I will take 3 variables. Ax square plus by square plus cz square plus 2hxy 2gxz plus 2fyz. Okay, here let what is x value? How many variables? 3 variables. Therefore, what is x transpose becomes xyz. xyz. Now, what is I have to write the coefficient matrix now. What is the procedure? Let us denote x as 1, y as 2, z as 3. Z as 3. Z as 3. Kalpana, are you there? Sujit Reddy? Sujit Reddy? Sujit Reddy? Are you there? Hello? Hello? Sujit Reddy? Charanteja? Charanteja?
Yes, sir.
Can you tell?
What, sir? Sir, I can tell, sir.
Yeah, come on.
First row is x coefficient, sir, x square coefficient.
That is good. What is that? X square coefficient? A.
A.
Let us fix diagonal positions first, okay?
Yes, sir. And
Next.
then 2 position, y square coefficient B.
Okay. Please stop. Sanjana, are you there? Sanjana? Sanjana? So all of you just you are switching on this presentation and leaving the classroom, right? This is the situation. What happened? Sanjana, are you there? No, you are not there. So all of you switch on your video. Sujit Reddy? Sujit Reddy? Sanjana? క్లాస్ సిఆర్
సార్
వీళ్ళందరికి absent వేసేసి. ఓకే, నెక్స్ట్ క్లాస్ నుంచి వీళ్ళని లాగిన్ చేయను. ఓకే
సార్ సమ్ మెసేజెస్ ఇన్ టెక్స్ట్.
ఇగో నేను క్లాస్ చెప్పేటప్పుడు మళ్ళీ మెసేజ్ చూడలేను. నా వర్డ్ ఫైల్ ఇది ఆటోమేటిక్ సైమల్టేనియస్గా పక్క పక్కన ఉండవు ఇవి. విన్నావా? మళ్ళీ నేను మీ గూగుల్ మీట్కి వెళ్ళాలి. మెసేజ్ ఏం చేయాలి? నేను మెసేజ్ చూసుకొని రెస్పాన్స్ అయినప్పుడు. సంజన, ఆర్ యు దేర్? వన్ లాస్ట్ టైం దిస్ ఇస్.
Yes, sir. Actually, my mic was not working, so
What?
my mic was not working, so I'm responding now. I just texted in chat.
Every time when I am asking you, you will get a problem definitely, right? You will not respond directly. Some problem already existed for you. Two position. This is y square quotient. 3 position z square quotient, right? Next, this position is 1 2. 1 2 means what? xy, and here also 2 1 xy. So in xy quotient, this is 2h. Take one h here, another h here. Next, xz. Xz means what? 1 3 position. This position and 3 1 position. 1 3 and 3 1. So this is g. Half g is here, half g is here, among 2g. Next, similarly, 2 3 position. 2 3 means what? yz. Yz quotient is 2f. This is 2 3 and this is 3 2. So equally distributed f. This is the coefficient matrix. Is the coefficient matrix. Coefficient matrix. Then matrix form is what? Then matrix form is x transpose ax equal to xyz. And what is this? A H G H B F G F C into this is XYZ. XYZ. Okay. Now this is about quadratic forms. Now what is the question is here? Reducing quadratic form to canonical form. Reducing quadratic form to canonical form. For example, see, write this one. Reducing canonical form. Reducing quadratic form. Reducing quadratic form. Quadratic form to canonical form. Canonical form. This is also called as canonical form or sum of squares. Reducing quadratic form to canonical form or sum of squares. Okay, this is very very important. This is very very important. Same logic here. We reduce. Come on, first thing. You know orthogonal transformation. You know orthogonal transformation. I told you what is that? X1 square plus x2 square plus x3 square is transformed to y1 square plus y3 square, y2 square plus y3 square. Now here the procedure is what? Consider the quadratic form. What is the quadratic form? X transpose ax in matrix form. In matrix form. Okay. And here the matrix A. Matrix A is symmetric matrix. Here matrix A is symmetric matrix. What is meant by symmetric matrix? That is A equal to A transpose. All of you observe this. See, what is this matrix? Quotient matrix. First row is equal to first column. AHG, AHG. Second row equal to second column. What is second row? HBF. Second column is HBF. Third row GFC, third column. So is symmetric matrix. Is symmetric matrix. Same logic. Same logic. here this matrix also. What is this quotient matrix? This is also is symmetric matrix. Is symmetric matrix. Okay. Now, so in a quadratic form, what is this quotient matrix? Definitely it is a symmetric matrix. Now, reduce the matrix A to diagonal form. Using what? Similarity transformation. Using similarity transformation. What is that similarity transformation? P inverse AP equal to D. D stands for diagonal matrix, where diagonal positions are eigenvalues of A. But the thing is here, this is important, but since the matrix A is a real symmetric matrix, that means the value entries are real symmetric matrix, the eigenvectors of A are pairwise orthogonal. That is, just I'm giving hint, x1 transpose x2 equal to x1 transpose x3 equal to x2 transpose x3 equal to 0. Okay, that means inner product. This is called inner product of x1 x2 x1 x3 x2 x3, all possible products of matrices that must be equal to 0. That is called pairwise orthogonal. When pairwise orthogonal vectors are there, eigenvectors are what? Pairwise orthogonal. Then normalize these eigenvectors. Whenever orthogonal is there, we have to normalize them. Normalize these eigenvectors, that is x1 by norm x1, x2 by norm x2, x3 by norm x3, where one thing I will write, x1, if I consider x1, y1, z1, what is this? Is norm means what? Norm x1, normalizing means what? x1 is divided by square root of sum of squares, y1 square plus z1 square, y1 by x1 square plus y1 square plus z1 square, z1 by x1 square plus y1 square plus z1 square. This is called normalization. Divide each value by the square root of the sum of the squares. Similarly, norm x2 and norm x3 can be calculated. Okay. Then group these three normalized eigenvectors to produce the matrix transformation, which is also called as what? Model matrix or model matrix P. That is, what is P stands for? Now, what is I have to consider? x1, not x1, normalized x1. Next, x2 by norm x2, x3 by norm x3. This is the matrix. Which is called, now onwards, normalized model matrix. model matrix or matrix transformation, simply normalized model matrix. Okay, since x1, x2, x3 are pairwise orthogonal, P is orthogonal matrix. P is orthogonal matrix. P is orthogonal matrix means what? Therefore, what we have? P into P transpose equal to I, right? That is P inverse equal to what? P transpose. P inverse equal to what? P transpose. Hence, now this is the final conclusion. Hence, to reduce a symmetric matrix, real symmetric matrix of a quadratic form to diagonal form, hence to reduce a real symmetric matrix A of a quadratic form to diagonal form, the similarity transformation. Always diagonal form means what? Similarity. Okay, the similarity transformation, what is that? P inverse AP equal to D becomes, what is this P inverse now? P inverse is nothing but P transpose becomes what? P transpose AP equal to D. P transpose AP equal to D, and what the D stands for? Same, no change here. P inverse AP equal to D becomes, here P inverse AP is called, now what is this? Since P is orthogonal matrix, is called, the similarity transformation becomes what? Similarity transformation, P inverse AP becomes, instead of P inverse, we have P transpose, and P is orthogonal, therefore P is called orthogonal transformation. This is important. Okay, right? Now, after diagonalization of A, diagonalization of A to D, the quadratic form, what is the quadratic form? X transpose AX reduces to, A reduces to what? D. X transpose DX. What is this one? X transpose DX means if this is three variables, this is lambda 1 0 0 lambda 2 0 0 0 lambda 3, and this is XYZ. For example, just I'm taking 3 by 3 is equal to what? Simply lambda 1 x square, lambda 2 y square, lambda 3 z square. This one, that is quadratic form, is transformed to what? This one, which is called canonical form, or this is sum of squares. This is the orthogonal transformation to reduce a matrix A, or to reduce a quadratic form to diagonal form, nothing but canonical form. So I am giving a brief procedure for this. Procedure to reduce stepwise, to remember, to reduce quadratic form to canonical form. Okay, step 1, find coefficient matrix. Find quotient matrix A of the quadratic form. Step 2, find the eigenvalues and eigenvectors. Generally, we solve the problems 3 by 3. Eigenvalues lambda 1, lambda 2, lambda 3, and eigenvectors x1, x2, x3 of matrix A. Right? Find the quotient matrix A of the quadratic form. Right? Always remember, what is this A matrix? It is a real symmetric. Definitely, for a quadratic form, what is a quotient matrix? Real symmetric matrix. Third step, since A is symmetric, right, and the eigenvectors must be pairwise orthogonal. This is very important. Okay, pairwise orthogonal. You have to check pairwise orthogonal. That is what x1, x2. If I consider, then take one transpose. If I consider x1, x3, take any one transpose. Next, similarly, x2, x3 transpose equal to 0. Okay. In this step, if any eigenvector is not pairwise orthogonal, then first make them as pairwise orthogonal. This is very important point. If any eigenvector is not pairwise orthogonal, then first make them as pairwise orthogonal. That is, after this only, now normalize each eigenvector. Normalize each eigenvector. That is x equal to, if I write like this, that is x equal to xyz. If x equal to xyz, x by norm x is nothing but x by root of x square plus y square plus z square, y by root of x square plus y square plus z square, z by root of x square plus y square plus z square. This is normalization. Okay, next step. Fifth step. Group the normalized eigenvector. To form the normalized model matrix. Or also called as what? Matrix transformation. Group the normalized eigenvectors to form the normalized model matrix transformation P. That is, P is what? Generally we consider, I told you already, 3 by 3 matrix x1, x2 by norm x2, x3 by norm x3, x3 by norm x3, x3 by norm x3. Okay, now after normalized. Now what is this? This matrix P is what? This matrix P is orthogonal matrix. P is orthogonal matrix. That is what? P inverse is nothing but P transpose. Now, which step? Step is 6. Step 6. Now, the similarity transformation. Now, the similarity transformation. P inverse AP equal to D becomes, in place of P inverse, I have to write P transpose. That's it. P transpose AP equal to D. This is lambda 1 0 0, lambda 2 0 0 0, lambda 3 0 0, lambda 3. Okay. Similarity transformation becomes, which is called orthogonal transformation, which is called orthogonal transformation. To reduce A to D. To reduce A to D. This part is over. Next, seventh one. Then, using orthogonal transformation, the quadratic form, what is that? X transpose AX reduces to X transpose DX. That is, X transpose DX is nothing but XYZ, and here lambda 1 0 0 lambda 2 0 0 0 lambda 3 0 0 lambda 3 into XYZ. Capital X is column, X transpose is row. So what is this becomes? This equal to clearly lambda 1 X square, lambda 2 Y square, lambda 3 Z square, which is called canonical form of the quadratic form, or sum of squares form. Done. This is the final answer. This is what? This one, X transpose DX, is the canonical form. Okay, this is the procedure. And if any doubts, it will be clear in the problem. Okay, let me solve one problem. I'm solving the exercise problem. I will continue up to 1:15. I will not take from 2 at 2 o'clock also. Let me take, and one more important point. What is this one? This is seventh one. Eighth point. Let me write the remaining characteristics also. Eighth point. If all the, you write like this, the number of positive terms, in canonical form is called index of quadratic form. Index of the quadratic form. Next, ninth point. Difference between positive and negative terms. Positive terms and negative terms. Negative terms in the canonical form. Is called signature. Of the quadratic form. Okay. Now, 10th point. In 10th A, I'm telling, if all the eigenvalues, are positive in canonical form, then it is called positive definite. Then it is called then quadratic form, you say. Then quadratic form is called positive definite. Next one. If the eigenvalues are positive and at least 1 is 0, at least 1 is 0, then quadratic form is called positive semi-definite. Positive semi-definite. Next, point C. Point C, negative definite. If all the eigenvalues are negative, then quadratic form is called negative definite. Negative definite. Okay. Next one, D. If the eigenvalues are negative and at least 1 is 0, then quadratic form is called negative semi-definite. Negative semi-definite. Okay. And last point, if the eigenvalues are positive and negative, all are there, positive and negative, then quadratic form is called indefinite. Quadratic form is called indefinite. These are the properties of the quadratic form. Okay. Positive definite means eigenvalues are positive and at least 1 is 0, positive semi-definite. Eigenvalues are all negative, negative definite. Negative and at least 1 0, negative semi-definite. If eigenvalues are positive and negative combinedly are there, then quadratic form is called indefinite. Now, first problem, let me take, reduce the quadratic form reduce the quadratic form 6x square plus 3y square plus 3z square minus 2yz plus 4zx minus 4xy to a sum of squares. Okay. And the remaining, or we have to discuss all the properties again. Solution. The given quadratic form is 6x square plus 3y square plus 3z square minus 2yz plus 4zx minus 4xy. Okay. Now, first write what the matrix form. Stepwise, the matrix form of quadratic form is, what is that? X transpose AX. Here, what is X? I told you this is, there are 3 variables. X means X, Y, Z. And all of you, now Sanjana, you tell what is A. X denotes 1, Y denotes 2, Z denotes 3. Yes? Don't waste time. Come on.
Yes, sir.
Now, what is 1 1 position?
6. Answer, sir.
6. Good. What is 2 2 position? 2 2. 2 2 means y into y square quotient.
3, sir.
Next, what is 3 3 position?
3.
3. Now, this is what 1 2 position, right? 1 2 2 1. That means 1 2 2 1 means what? XY quotient. What is XY quotient?
Four, sir.
Minus 4. Minus is there, no? So minus 4. In that minus 4, half here, half here. Next one, 1 3 position. 1 3 means xz. Xz means zx. Its coefficient is 4. In 4, half here, half here. Next, lastly, 2 3 position. This is 2, this is 3. Minus 2 is there. So minus 1, minus 1. Minus 1, minus 1 is a symmetric matrix. You can check. A equal to A transpose is a symmetric matrix. For a quadratic form, the quotient matrix is always symmetric, right? Next, immediately they find the eigenvalues. The characteristic equation is determinant of A minus lambda I equal to 0. That implies 6 minus lambda. Already, did we solve this problem? Check it. Anyone? Already solved chesam idi? Anyone? Now, coming to eigenvalues, this is 6 minus lambda, 3 minus lambda whole square, 9 plus lambda square minus 6 lambda minus 1. This is plus 2 into this one gone. This is minus 6 plus 2 lambda, and this is plus 2. Next, plus 2 into this one, this is 2 minus 6 plus 2 lambda equal to 0. So 6 minus lambda, this is lambda square minus 6 lambda plus 8 plus 2 into what is this, 2 lambda minus 4 plus 2 into, I think
we solved this, sir.
We solved
Yes, sir.
Yes, sir.
what are
Eigenvalue, sir, 2, 2, 8.
Very good. 2, 2, 8. Eigenvectors also there na?
Yes, sir.
Yes, sir.
So already this is solved problem. The eigenvectors. Solved problem. Previous class. Okay. Exam lo idu rayadabba. Solved problem previous class ante కుంటారు answer doraka. Don't write this one. So you have to solve this one. The eigenvectors are చెప్పండి. Eigenvectors are
x1 equal to 1, 0,
lambda
minus 2.
Lambda equal to 2. X1 is
1, 0, minus 2.
okay. What is x2?
1, 2, 0.
Okay, 1 2 0. Already we calculated this for lambda equal to 2. For lambda equal to 8,
2 minus 1, 1, sir.
2 minus 1 1. Now listen carefully. After getting the eigenvectors, we have to check whether these eigenvectors are pairwise orthogonal or not. Pairwise orthogonal or not. Now, for this, what is the procedure? I told you x1 transpose into x2. x1 transpose into x2. So what is x1 transpose becomes row matrix 1 1 0 minus 2 transpose, and this is 1 2 0. If I multiply this 1 what is this is 0, this is also 0. So 1 not equal to 0. That means x1 and x2 are not pairwise orthogonal. Okay. Next one. Let me try x1 transpose x3. 1 0 minus 2. And what is the third one? 2 minus 1 1. So product is 2. This is 0 and minus 2. Yes, this is 0. This is true. x1 and x3 are pairwise orthogonal. Now another one. x2 transpose x3. x2 transpose means 1 2 0. This is 2 minus 1 1. This is 2 minus 2, and this is 0. So this is also 0. Okay. Clearly x1 and x2 are not pairwise orthogonal. Not pairwise orthogonal. Is this clear? Up to here clear? All of you? After getting eigenvectors, we have to check whether these eigenvectors are pairwise orthogonal or not. If pairwise orthogonal, well and good. Now here we are getting a situation where x1 and x2 are not pairwise orthogonal. Therefore, we have to make them as pairwise orthogonal. As pairwise, we have to make them as pairwise orthogonal. As follows. Let's see, all of you see, there is no mistake in x3. Why? Because x1 transpose x3 is 0, x2 transpose x3 is 0. That means there is a mistake either in x1 and or x2. So I have to assume a new one. Choice is yours. You can change x2 or x1. I am changing x2. Let x2 equal to ABC. What I am assuming? X2 equal to ABC such that how ABC are determined such that x1 transpose x2 0 and x2 transpose x3 0. This must be x2 is pairwise orthogonal with x1, pairwise orthogonal with x3. Okay, this x2. Okay. Now what is this meaning? Now from these two, first one, x1 transpose x2 equal to 0 gives. What is x1 transpose? 1 0 minus 2. 1 0 minus 2 into what is x2? ABC. So what is this becomes? A minus 2c equal to 0. So A equal to how much? 2c. Keep this one. Another expression is what? x2 x3 equal to 0 implies what? What is x2 transpose? X2 transpose means ABC. And what is x3 becomes? What is x3? 2 negative 1 1 equal to 0. This implies what? 2a minus b plus c equal to 0. Therefore 2a minus b plus c equal to 0. Put a equal to 2c. Then what is this? Is 4c minus b plus c equal to 0. Then what is b equal to 5c? So combining these two equations, for c. For c, what is the first expression? From this I will get a by 2 equal to c. From this I will get b by 5 equal to c. So a by 2, b by 5, c by 1. Okay, that is ABC values. These are the ABC values. Therefore, what is x2 is 2, 5, 1. Therefore, now x1, what is x1? 1 0 minus 2, 1 0 minus 2, x2, the new vector now I got, which is pairwise orthogonal, and x3, what is x3? 2 minus 1 1, 2, x3 equal to 2 minus 1 1 are pairwise orthogonal, This is the next step. Okay, first step is what? Write the matrix form, then find A. For A, find eigenvalues, then find eigenvectors, check orthogonality of eigenvectors. If any one is not equal to 0, then correct it using like this procedure, your choice. Here x1 into x2 not equal to 0 means there may be a mistake in x1 or in x2. So I'm taking x2. You can take x1 also, doesn't matter. Then x2, I am getting new x2 as what? 2, 5, 1. Now all these three eigenvectors are pairwise orthogonal. Now after getting pairwise orthogonal, now normalize each eigenvector. Normalize these eigenvectors as, what is the first one? x1 by norm x1 equal to, what I told? 1 divided by 1 square plus 4 root 5. Next, this is 0. This is minus 2 by root 5. Next, x2 by norm x2. What is that? This is 2 5 1. 2 by 2 square, 2 square, 5 square, 1 square, 25 plus 5, 30, root 30, 5 by root 30, 1 by root 30. Next, x3 by norm x3 equal to, this is 4 plus 1, 6, 4 by 2 by root 6 minus 1 by root 6, 1 by root 6, sum of squares of all values. Okay, now grouping these normalized eigenvectors, we get normalized modal matrix. We get normalized modal matrix or matrix transformation. What is that? P. Matrix transformation P, that is P equal to what? X1 by norm X1 X2 by norm X2, X3 by norm X3. That is implies P equal to, what is X1 by norm X1? Let me see. 1 by root 5, 1 by root 5, 0 minus 2 by root 5. Next, what is X2? 2 by 2, 5, 1. 2 by root 30, 5 by root 30, 1 by root 30. And next one, 2 minus 1, 1. 2 minus 1, 1. This is the modal matrix. Now, using orthogonal transformation, you can write directly. Okay, no need to write again similarity transformation. Using orthogonal transformation, we have, what is orthogonal? Similarity transformation is what? P inverse AP equal to T. Now orthogonal means what? Orthogonal means what? This inverse becomes what? Transpose. That's it. This is, which is an orthogonal matrix. Which is an orthogonal matrix. D value is what? Lambda 1, 0, 0, 0, lambda 2, 0, 0, 0, lambda 3. Okay. That is equal to what? 2, 0, 0, 0, 2, 0, 0, 0, 8. 0, 0, 8. That's it. Then the quadratic form, what is that? X transpose AX is reduces to canonical form. X transpose in place of A, write D, dx, that is equal to lambda 1 x square, lambda 2 y square, already I have written, lambda 3 z square, lambda 3 z square, that is equal to, you write directly. In the next page I will write, that is equal to 2x square plus 2y square plus 8z square is the sum of squares. Is the sum of squares form. Okay, next. Now properties. Since eigenvalues 2, 2, 8 are all positive, the quadratic form is positive definite. And in canonical form, all the terms are positive. All the terms are, how many terms? All the 3 terms. Totally 3 terms are there. All the 3 terms are positive. All the 3 terms are positive. The index of quadratic form is what? 3. Number of positive terms is 3. And what is the signature? number of positive terms minus number of negative terms. There is no negative term. So index is 3, signature also 3. And the quadratic form is what? Positive definite, since eigenvalues are all positive. All are positive. Any doubts with this problem? Any doubts? I have clearly given